diamond ring for my queen. You gon' wait me till Jesus come. Why when I talk? Pocket full floss, money, honey. Forget about Suzanne. So since we don't have all the equipment like cameras and all this stuff, so just use one of the webcam from my computer. So we're gonna start with these tools and give people knowledge, because that's how they say, start with what you have, and then from there you're gonna elevate it. You're gonna elevate it, and things gonna propagate it, and just me, and things gonna improve slowly, because you can't reach down top before start from the bottom. Otherwise, then you're gonna break and start from bottom of phrase. So I'm gonna start with the tool that I have. Hey king and queens, how you doing, man? Trying out the African greatest of all time. We gonna fashion this world, man, till the last day, man. And man about decide to take my break. So let's credit these leggings, baby. So let's go, man. So we have a question right here. Not all of them. It's about derivative table. So we're gonna have to use derivative table. So just in case you have no idea what it is, make sure you memorize this table. It's very, very important. So now let's start for the first question. So let's say y equal to arctan, and then you have these function like y equal to arctan. So everything in front of tan is function. Like here, y square equal to cos inverse. So everything in front of the cos inverse is function. See what I'm saying? Just like here. So whenever you have, so this is arctan. So if it's arctan, you're gonna have to go to the tan derivative table. What is arc? Arctan, if somebody say arctan of whatever we have, so anything in front of the arctan, we call it function. Just like if somebody give you arctan x, let's say x cube. So all this is function. So what we're gonna do, if we derivate these, all of these functions, means what we're gonna do here, look, you have to derivate whatever is here in front of the arctan. So means anything we see in here, if we derivate this, we're gonna have to derivate any function which is in here. So we're gonna say f dash, means when you derivate f function, you're gonna get f dash. And they say divide, say 1 plus, that's how the formula say, g square, means take your function and then square. So function for this case is f of x. So say your f of x and then square. That's how you do. So for this case here, I'm gonna say derivate arctan inverse, meaning I'm gonna have to derivate anything which in front of the arctan. So I'm gonna say derivate anything from the arctan. So this is add 3, and then we're going over 1 plus, what we're going to plus all your function according to the formula. Take all your function, then you square. So I'm going to take my function. For this case, my function is add cube, and then what I'm going to do, I'm going to square. So this is going to give us, if I derivate x cube, means this 3 is going to go to the back. It's going to be 3, and then x, take your power, minus 1. 3 minus 1 equal to 2, and then you over 1 plus x, 3 times 2 equal to 6, and this is going to be our answer. So now let's go back to our equations. For this case, y equal to tan of all these function. So I'm going to have to derivate all this function, and the answer I'm going to get, that's going to be our answer, which you're going to write on top. So it means all this function I have to derivate, and after get an answer, king and queens, I'm going to have to write that answer on top is derivative of this function. So now let's go. So we're going to say, I'm going to raise because we don't need these. So raise this one quick. So what I'm going to do for the first equation, I'm going to have to tag this one right here in derivative. So I'll say d dy d dx of left hand side, and then derivative also d dx of right hand side. But what is the right hand side? It's ln e x power x cube, but there's a square here, square right there, and then let me write clear so you can see. So that's x square, I think you can see there. So now we say we over, no, excuse me, so we say d dy on the left, and the right hand side we got arctan. I kind of forgot arctan, my apologies. So we say on the right hand side I have arctan, right, and then we have a ln of e, and then power 3, and then we got x square. This 3 has to be clear, x square, and then you over x squared minus 5 in the bracket. Excuse me. So according to the definition of arctan inverse, when you derivate arctan inverse, what you got? You got derivative of a function. What is a function? Means derivate all this function which is in front of a term. So this time I say, I'm gonna write my line because this is derivate arctan. Means derivate any function which is in front of the term. So we're gonna say derivate all of this. Means all of this, which is ln e x square cube root, and then you divide by your x square minus 5, and then we got 3 right here, brother and sister. And then we're gonna over, we're gonna over 1, because that's our formula saying that we plus square of the function. So this function which is given, we have to square. So ln e square root of 3 power, you know what I'm saying? Let me write clear because I want to look like next to it. So let's say ln, and we got e, and then this is power 3 x squared, and then we over 3 x squared minus 5. Right, so now what we're going to do, if it's me, what I'm going to do, I'll take the numerator and derivative side. So let's take a numerator. So take numerator, and then derivative. So when I derivative, the business is done. So what I'm going to do, take my numerator and derivative. So numerator say, so our numerator, excuse me, if I had to derivative, you know what I'm going to do? I'll do like that 1. You know, whenever you do something like in basic steps, means you're going to make mistake. You know what I'm saying? So I'm going to say let me just let equal to certain letter. Let me say let. We do here let y. You know why I do that? Because whenever you have a y, ln of e, I'm going to apply ln. You know what I'm saying? So I'm going to say, excuse me. No, excuse me, sorry. Before I do that, you know what I could say? Excuse me. The easy step. Whenever you have not, if somebody give a ln of, let's say, e power x, whenever you have a ln e power anything, take this stuff to the back. Is acceptable. So x ln of e, but ln of e equal to 1. So I'm going to do the same thing before I differentiate. Means all this power is going to go back before ln of e. So I'm going to say all the power. Same here. All this is going to go to the back. All this is going to go to the back. So that means, excuse me, so I'm going to write this part here, means this stuff is going to go behind ln e. So same as say ln e, and this stuff is going to go to the back, which is going to be x squared power 3, see, and then over, so this ln of e equal to 1, means all this equal to 1, ln of e equal to 1. So if ln e equal to 1, meaning this half is going to be 1, so on top we only left with x cubed squared, and then over, and then even this one also, all this stuff is going to go to the back here, means this stuff is going to go to the back. So then even here we're going to have only this part here, because this stuff is going to be equal to 1. So x cube root of x squared. So now I'm going to have to rewrite what I have there. So I'm saying, so I'm going to raise this. So let's rewrite. So if you have to rewrite that stuff, it's going to become, see, so we're going to say dx here on the left. When you differentiate to y, is going to be, excuse me, I think you cannot see that clear. So d, when you derivate y, is going to be dy, and this is going to be dx. Means when you derivate y, dy equal. Now we're going to take this one here. So if we take this one here, we're going to get, we said this is going to come to the back, so it's going to be x cube root of x squared, and the ln of e, but we said ln of e equal to 1, so I'm not going to write there, because anything times 1 is that something, so I'm not going to write this. So just x cube root of x squared, and then we over, that's a numerator, and then here we're going to have a cube root of x squared something here. Excuse me, I made a mistake here. Why did I make a mistake? Because we still have we have not yet derivative. So we still have our d dx, and this half go to the back. So it's going to be x square, and then we have a cube root, and then we over, what we have over x, there's a cube root here, and then we have x square minus 5, and then all this stuff, and this stuff we say is going to come to the back. So we have a 1 here, and then we say plus, this is going to become x square cube root, and then this also you're going to over cube root, and then you have the x square minus 5. So I'm saying stuff like this. So now you see it's going to be easy for me to differentiate. It's going to be very easy for me to differentiate. Since these stuff have the same root, I can put them together. If somebody give you, let's say, power 4m over power 4t, this here may say m over t, both of them power 4. So now I'm going to say power 3, root of 3, so I can put them together. So I'm going to say this here may say d dx, and then same root. So root of 3, and now on top is going to be x squared, and here is going to be x squared minus 5, and then over this side here just a 1, and the plus also we're going to do the same game here. So it's going to be cube root x squared, and then over x squared minus 5. So next game I can just differentiate the numerator, and the game is finished. So I'm saying the game is going to be finished. So now I'm going to say if I differentiate the numerator, remember this is like a one thing. So if I differentiate the numerator, it's going to give me, so first before I differentiate, let me write as a power. So this let me say we have to differentiate the numerator, which is, somebody could have done in quotient rule, but I think I will do this way, is a power rule. So this, I'm not going to write the root anymore. I'm going to say this, let me say x squared over x squared minus 5 power 1 over 3. Now this also is going to become 1 plus cube root of x squared over x squared minus 5. So what I'm going to do, I'm going to differentiate as a power rule. So I have all this stuff. 1 over 3 is going to go to the back. So dy dx equal dy dx, excuse me, I think some people cannot see, dy dx equal, so I'm going to differentiate all the stuff there. So if I differentiate all the stuff there, I can take this aside and differentiate here, and then write the answer back. So let me leave this and take this aside. So say, okay, let's differentiate d dx x squared over x squared minus 5, and then go 1 over 3. So king and queens, we take 1 over 3 at the back, so it's going to be 1 over 3, and then we're going to write this exactly. X squared over means all these exactly. X squared over x squared minus 5, and then 1 over 3 minus 1, we get negative 2 over 3, negative 2 over 3. And then the next step, I'm going to have to differentiate whatever is in here. And the final answer, I'm going to write here. So now let's differentiate. So this is a quotient rule. So since this is a quotient rule, we're going to put the denominator constant. So I'll take this and differentiate aside and put the answer over there. So I'll say denominator constant, so x squared minus 5, and then, so I differentiate this separately, like this one. And then when you differentiate x squared, we get 2x and then minus. Now this x squared is constant, and then we differentiate this, which is going to give us 2x. This is going to be 0 over square of the denominator, so x squared minus 5, and then square. So what I'm going to do, excuse me, I'll take this and plug in there. So now this stuff here is going to become, I could have said 2x squared. I can simplify further, excuse me, and say this, let me say x squared times 2 is going to be 2x cubed, and then 5 times 2x, negative 10x. Now you go negative x squared times 2x is going to give us negative 2x cubed, and then we over. Now this is going to become x squared minus 5 squared, this and this cancel. So we got negative 10x over x squared. So all this stuff here is gonna give us, excuse me, so it's gonna give us, I hope everybody can see there, just in case if you didn't see. So you say, oh, this, we got that one, so this and this cancel. So we're gonna be left with negative 10x over x squared minus 5 squared. So this is gonna go in here, right? So we're gonna say, right, so our final answer for, if we derivate this part here, okay, we're gonna get negative 10x over x squared minus 5. So we're gonna raise the other stuff we don't need. Means we did differentiate by tagging it here, and then we got that one. So we don't need this part anymore. You know what I'm saying? But in your solution, you can keep it. So I'm gonna raise this part because we have insufficient space here. So our question is gonna become, finally, I'll take this one and plugging it over there. So say finally, if I differentiate dy dx, final answer equal to, take this stuff and plug in, excuse me, oh okay, so we had a 1 over 3, so we're going to say this come back, so it's 1 over 3, and then we say we drop the way how it is, which is x squared, and then over x squared minus 5, and then 1 over 3 minus 1, negative 2 over 3, and then we multiply by negative 10 x over x squared power 5 minus 5 squared, and then all this stuff we over, you're gonna have to over what? 1, and then plus cube root of 3, and you got x squared, and then x squared minus 5. Okay, so finally I can reciprocate this because this one has a power negative, and it's never be right to leave your answer as a power negative. So now I'm gonna say, I'm gonna reciprocate this to the denominator. So here we're gonna have a 1 over 3 finally, our final answer, and then this is gonna come at the denominator because this is power negative. So it's gonna be here, x squared is gonna come under this 3, x squared over x squared minus 5, and then here it's going to become 2 over 3 because this power negative is going to come under this 3, positive is going to become, and all this stuff is going to be at the numerator, which is negative 10 over x squared, and then minus 5 squared, and then all this stuff over 1 plus cube root of x squared over x squared minus 5. So this is the final answer, man. See, king and queen. So this is going to be our final answer. However, you can simplify further by taking all this stuff and put it here. The denominator is acceptable too. So if this time my channel, you know, which I would do that, you know, of course, because see, this term here and this is the same. So I'll take this one here, which is going to have power negative. I can do that too if you want to take all this stuff out of the denominator, see, and bind them together, because whenever you have, let's say, a power x times a power y, see, you're going to say same base and add the power. So if you see this on here, if you want to simplify further, but you know, there's no necessity, I'll stop there. Thanks so much for your time, man. So for the first question is done already. So now let's go for the second equation. Second question is very, very easy. So we're gonna
my queen, you gon' wait me till Jesus come. Why when I talk, pocket full floss, money, honey, forget about Suzanne.
So since we don't have all the equipment like, you know, cameras and all this stuff, so just use one of the webcam from my computer.